Today we get to do solving inequalities. These are going to have many of the exact same rules as solving equations, but there's going to be one little exception. So first let's start with adding and subtracting. It literally works the exact same way. So try and get W by itself. So I'm probably going to subtract W. And that's going to give me, 1W plus 3 is greater than 9, so I'll subtract 3. W is greater than 6. What's going to be different is I'm going to go ahead and graph these. This is going to be a number line, so draw a line, put some arrows on the end to show that numbers go on for infinity to the left and to the right, and put a line in the middle and mark that your answer. So since my answer was 6, I marked it 6. There are, you might notice, two different ways that these signs can look. I have a greater than sign, and I have a greater than or equal to sign. So if it's a greater than or a less than sign, let me maybe put this up here. If it's a greater than or a less than sign, that means that the variable is going to approach a number really, really close, but it's never going to actually get to that number. So if I say that W is less than 5, let's say, that means W can be 4.9 and 4.999999999. So many nines I can't even write them all. But it's never going to actually equal 5. Whereas if I have greater than or equal to, or less than or equal to, now W can equal that 5. That one little line makes all the difference. So how do I show that on a graph? Well, what I'm going to do is use either a circle or a dot. And so the greater than or less than ones get circles, and the greater than or equal to and the less than or equal to is going to get a dot. So since this was a greater than sign, it's going to get just a circle. Now it says W is bigger than 6. Give me an example of a number bigger than 6. 7, 10, 100. Okay, 7, 10, 100. Would that be on the left side or the right side of my 6? Be on the right side, so that's the side we get to shade. Just like that. Now there is another way that you can make these graphs. You could do, make my graph here, here's my 6. You could just draw an arrow and point it that way. That would mean the same thing. Let's go ahead and try where we have the multiplication and division. When you multiply or divide both sides by a negative, you're going to need to flip the sign. Okay, flip that sign. So check it out. Solve each inequality. Graph the solution set on a number line. Okay, what I'll do is divide by -4, because that's what I need to do to get x by itself. Whoa, stop! If you remember from your freshman year, I used to like scream that, right? Like, stop! And everybody jumped and it was funny. Did you divide by negative? Yes? Then flip the sign. Like so. X is less than -24 divided by -4 is a positive 6. Okay, now we can go ahead and number line graph that. Circle or dot. Well, since it's the equal to, it's going to be that dot. Remember, back in the day, I used to say like extra ink, extra ink. Okay? Since the equal sign has that extra ink with the equal part, that's where it's going to be a dot. So this one is a dot. It says x is less than 6. Numbers smaller than 6 would be like 0. That would be on the left-hand side. So I can graph it like that, or I can graph it like that. Either way. Okay? Let's do some multi-step. Actually, let's do a random example over here. So let's say, pretend for a minute, that I have maybe 24 is greater than 3x. So to get x by itself, I'm going to divide by 3. Whoa, stop. You're dividing. Was it negative? No. If it's not negative, you don't have to flip the sign. Okay, but now my answer is kind of like backwards. I want to write these so that the variable is on the left-hand side. So I'm going to do x and 8. I'm going to have to switch this sign if the, kind of like alligator teeth. If it's eating the 8, it should still be eating the 8 when you flip it over like that. Like so. Alright, so this would be a circle. X is smaller than 8, so it shades to the left. Okay, we can go crazy. Let's do some multi-steppers. Let's see. Let's do 3a. If I multiply both sides by 5, my 5's will cancel. And now I have negative 15x is less than or equal to negative 4x plus 22. If I add 4x to both sides, that's going to give me negative 11x is less than or equal to 22. If I divide by negative 11, oh, stop, it was negative. X is greater than or equal to negative 2. Circle or dot, this one would be a dot, extra ink, extra ink. X is bigger than negative 2, so shade to the right. 3C just shows that you can distribute. Notice that I am on the on the left side multiplying by that negative 6, but I'm not going to the other side of the equal sign. So I do not have to switch the sign. It would just be 24v minus 18 is still less than or equal to 20v plus 6. And then I could solve from there. We use inequalities when we talk about like bills and things. Here we have Rosa, and she needs to stay under $70 a month, but her phone plan charges her for minutes after she goes beyond her free minutes. Believe it or not, that used to be how cell phone plans were. It didn't used to be all unlimited. And so that's how we can figure out, like, well, how many minutes can she talk on the phone before she exceeds her budget?